Hi everyone, we are starting Unit 3 today. Unit 3 is all about parallel and perpendicular lines. So we're going to dive into Lesson 1, which is specifically just talking about the different angle types that get formed due to transversals. So I have this warm-up here started for us. It's similar to what we did last unit, where if we are given an angle measurement, can you find the rest of them? So if we know that angle 2 is 62 degrees, oops, I wrote that funny, 62, there we go. Could we find the rest of them? And so looking at these ones, again, my favorite angle pair is the vertical angles. So we know that for sure angle 4 would be 62 degrees. And why do we know that? Well, we know that they're vertical angles. And then we know that angle 1 and 2 form a linear pair. So what we can do is use our linear pair knowledge. And we know that linear pairs always add up to 180 degrees. So what we can go ahead and do is say that angle 1 has to be equal to 180 subtracted from 62, which leaves angle 1 being 118 degrees. And then last but not least, you could use linear pair idea or vertical angles to find angle 3 is also 118. Here is our edited calendar. As I mentioned on Friday, I had to move some things around to accommodate the retreat. That's what it was that you guys did yesterday. So this is our new calendar. You can take a look at it. And I'll jump right ahead to talking about what we're doing today, which is parallel and perpendicular lines. Now, specifically starting with parallel lines. Parallel lines are two lines that do not intersect. So they will never intersect each other. And they also do have to be on the same plane. For example, in our image off to the right side here, lines M and N we would consider parallel. Here and here, they're on the same plane. And we have special notation. So in your diagram, the notation is always going to be these red arrows. So the red arrows in a diagram will tell you that two lines are parallel, as well as whenever you're writing it, you'll write it as M is parallel to N, and you'll use these two lines here to denote parallel. It's kind of the shorthand. So M is parallel to N. That's how you'll write it in proofs, or you'll see it on homework sometimes. Another vocab word that we have is skew. What skew means is it's just two lines that do not intersect and are not coplanar. So for example here, M and K. And last but not least, with parallel idea, we also have parallel planes. So not only lines, but planes can be parallel as well, as in this picture, T and U. So going to the next slide here, we're going to talk about just using a diagram, trying to analyze where these things appear. So we want to go ahead and try to think of segments or planes that describe these various things. So the first one is, could we find a line that is parallel to the line CD that also has the point A on it? So we're looking for a parallel line to the line CD. So I'm going to highlight CD here. We're looking for a line that is parallel to this one and has point A in it. To me, that looks like it's going to be this line here right across from it. So this would be line AB. And we're going to just make sure we use that correct notation with those arrows on top since it's a line. Now, when we're talking about skew, this one is saying, could we find a line that is skew to CD and also contains that point A? I'm thinking we could choose a couple of different ones. I think A to G could be one, as well as A to H. These ones both could be skew to our original line CD. I think I'll write AG for today. So line AG, if you wrote AH, I think that's an okay choice as well. All right, this next one, we're talking about perpendicular. And now I didn't put the definition of perpendicular in these notes per se, because we have talked about it in the past. Remember, perpendicular means that they meet at 90 degrees. And they have this special notation. It's like that upside down T. So when we're talking about perpendicular, we're looking for two lines that have the upside down T, or like most of our diagrams will have is that red box indicating that they are meeting at 90 degrees. So looking at our lines here, sorry, my dog's going crazy. We're looking for lines that are perpendicular to CD. So I'm seeing that this line segment looks like AD. If I'm highlighting it here, is meeting that line CD at that red box that we have. So that is our indicator that they are actually perpendicular lines. Last but not least here, we are looking for a parallel plane. So now an entire plane, so one of those sides of this cube. And we're looking for it to be parallel to EFG. And so EFG, it looks like, is this bottom plane here. So the one that is parallel is going to be the one above it. And this is going to be ABC, or plane ABC. Again, you could name this a couple different ways. If you wanted to do BCD, you could name it that way as well. Alrighty, looking at our next slide here, we just have some postulates. These postulates are just talking about how parallel and perpendicular lines can be formed. So the first one is the parallel postulate. It says that if there is a line and a point that is not on that specific line, then there is exactly one line that could be created through that point that would be parallel. Essentially what it's saying is that we couldn't make this line through this point P in this example because it wouldn't end up being parallel. So that would not work. So there's only one line that we can create. Very similar language for the perpendicular one. If we have a point and we're trying to draw a line that's perpendicular, there is only one line that's going to exist that we can draw that will perfectly be perpendicular. And so on this slide, what we're doing is talking about those postulates just a little bit more. So for example, if we have this image up above, we've got a line segment and we've got a point. We could say how many lines exist that will go through this point and be parallel. Well, we know that there's only one that is going to exist from that postulate above. Same idea here. How many lines will exist that will go through that point and be perpendicular? Well, we know that there's only one. Again, if we were going to draw those, we could only draw one line that is going to be perfectly parallel, and we can use our markings here. And we can only draw one line going through here that is going to be perpendicular. No other lines can be drawn. There's only one that will be parallel and one that would be perpendicular. Alrighty, then looking at some of our math definitions here. So this is kind of the star of our show. We're talking about our transversals. So we're talking about our transversals today. What a transversal is it's a line that intersects two or more coplanar lines at different spots. So for example, in these diagrams here, this would be an example of a transversal, these lines T. Again, it's a line that is intersecting two other lines or two or more lines. And what transversals do is they create different types of angle relationships. So we're going to go through those angle relationships today. What I have here for us is this transversal kind of diagram that we can fill in together so we can learn about these different types of angle relationships. Now we're really going to want to practice with these ones because we'll use them all of the time. But we'll just kind of go through them step by step. So looking at our diagram here, I have that transversal labeled. Transversal is this line that's cutting through. Again, we've got two coplanar lines here, and the transversal is cutting through them. Now what happens when that transversal cuts through them is we have exterior, top and bottom, and an interior created. So we kind of have these sections. What we can go ahead and do then is look at the angles that get created from these ones. So the first type of angle relationship that we have is corresponding angles. Corresponding angles are angles that are formed within our transversal diagram here. And they end up being kind of stacked on top of each other. So for example, one of the corresponding angles that we have is angle, oops, I'm moving things here, angles 1 and 5. Those ones are examples. We also would have 2 and 6, 3 and 7, 4 and 8. So it's angle pairs that are kind of stacked on top of each other. I'll write all those ones down. Angles 1 and 5, angle 2 and angle 4, angle 3 and angle 7, and lastly angle not 2 and 4. So sorry, let me go backwards. Angle 2 and 6 are the ones that go together here. Let's rewrite that. Angle 2 and 6, and angle 4 and angle 8. There we go. Good thing I caught that. When we're looking at these ones, what do all of these angle pairs have? Well, they all end up being congruent angles. So they are special in that way where all of these ones would be congruent. So we would say that angle 1 is congruent to angle 5. Angle 3 is congruent to angle 7, and so forth. So they're all individually the pairs congruent. Now, the second type of angle relationship that gets formed are vertical angles, and we have had the lovely time of already working with vertical angles, so we know that vertical angles are already congruent. But let's go ahead and just take a minute and identify where those vertical angles are. Again, those are kind of the ones that are across from each other. So in this specific image, we would say angle 1 and angle 4. We can see these ones are across from each other. Angles 2 and angles 3 are across from each other. They would be congruent. Angles 5 and angle 8, as well as angle 6 and 7. Uh-oh. I set them next to each other. Angle 6 and angle 7 would be congruent as well. All right, we're looking for same side and interior angles. So when we're looking at these ones, I'm going to kind of break this up so we can see it a little bit better, as like this might be the left side of your transversal and this is the right side of your transversal. So what we can say is same side would be angles 1, 3, 5, and 7. And on the right would be 2, 4, 6, 8. So looking at those same side and ones that are on the inside is angles 3 and 5 and 4 and 6. So they're on the same side. Let's locate those ones. Looking for your same side exterior angles, that would be like angle 1 and 7 would be a pair, as well as 2 and 8. Alternate interior. I'll maybe erase some of this work here so we can see these numbers better. Here we go. When we're talking about alternate, that means we're opposite sides and we're looking for the same side. So when we're looking at interior, that means we're looking at just this portion here, our interior angles. And now what we're going to be looking at is alternating, so on different sides of this transversal. So I might point out angles 3 and 6. They are inside or interior angles, but that one is on the left and one is on the right. Likewise, 4 and 5 would be a pair where one is on the left of measurement. These ones now are just outside angles. So angle 1 and angle 8 are exterior, and angle 2 and 7. Starting with the ones we originally had, we had vertical angles, which is one we know already, which is great. Those ones are congruent. They're opposites. Corresponding kind of match up, they align, and those ones are congruent. Going on to our next slide here. So we've got some more angle relationships to talk about. There's 6 total. We've talked about 2. These next ones kind of go hand in hand together. So the third angle relationship are kind of 2 names, we call them, either same side interior or consecutive angles. When we're talking about same side interior, essentially what it means is they're on the same side of the transversal and they are interior, they're inside. One of the fancy things about these ones is they are supplementary. So these ones will add up to 180 degrees. So these ones are supplementary. What we're going to do is go back to the last slide and we'll locate those and then write down which ones they are. So of each other and they're inside or they're interior. So again, I'll write those on this slide for us. This is angles 3 and angles 5, angles 4 and angle 6. So those are your same side interior. I think just to kind of keep this consistent here, let's go ahead and move down to the same side exterior angles, because these ones are very similar, where they're on the same side of the transversal, but this time they're on the exterior, the outside. These ones are also supplementary. So the nice thing about these same side angles, we can always think about them being supplementary. We'll just want to make sure we go back and see that they're either exterior or interior. So we'll go back and write these ones down. Angle 1 and angle 7, angle 2 and angle 8. Those are all same side and exterior outside angles. All right, 2 more to talk about. Going up to relationship number 4, the alternate interior angles. Alternate interior angles are fancy for the property that they are congruent. And when we're talking about this idea for alternate, that means they're on opposite sides. So relationships 3 and 5 are same side. Now alternates are opposite sides. And it's very similar where we had interior and exterior, same for the alternating 2. So when we're transversal and one is on the right. So again, summarizing those angles 3 and angle 6 and, oops, I wrote the word and there, and angle 4 and 5. Those ones are alternate interior. Last but not least is alternate exterior. Again, very, very similar. This time is just on the outside. It's the exterior. These ones are also congruent. So they are the same and they're on opposite sides. So again, that was angle 1 and angle 8, angle 2 and angle 7. So that is kind of our big chart of all of the different types of angles that we have. Again, we'll summarize them all. Then we talked about the same side interior and same side exterior angles. These ones are supplementary. They're always on the same side of the transversal, and they're either interior or inside angles or outside exterior angles. And then the last ones we talked about were those alternating ones. And those are either alternating interior or exterior, and those ones are always congruent. Now, last but not least, what I want us to do is just kind of practice. Now that we dumped all of those into our brain, could we classify what type of angles we have just based on one diagram here instead of all of them at one time? So looking at this first one, number 3, I'll zoom in on it. We have a transversal. I'm going to highlight it. So your transversal is that line going through your 2 other lines. And looking at this one, we are looking at angle 1 and angle 5. Now, kind of my thought process when we're looking at these ones is we want to say, okay, well, are they on the same side or opposite sides? And looking at these ones, they are on the same side. So we know that we aren't working with any exterior angle. Sorry, not exterior. We're not working with any alternating angles here. They're on the same side. Now, looking at these ones, they aren't both interior, because if they were both interior, one would have to be here, which it isn't. And they both aren't exterior because 5 would have to be here. So because they both aren't interior or exterior, these ones actually are the corresponding angles. So these ones would be corresponding angles. And just to test our knowledge a little bit, corresponding angles are always congruent to each other. So we would say angle 1 is congruent to angle 5. All right, moving on to this next one here, highlighting our transversal, boom. We are working with angle 2 and angle 7. And now looking at 2 and 7, I'm noticing right away that angle 2 is on the right side of this transversal that we highlighted. Angle 7 is on the left side. So this is already kind of a light bulb that we're going to be having an alternating relationship. We just have to decide if these are interior or exterior angles that we're looking at. I'm noticing that 2 is on the outside and so is 7. So these ones will be alternate exterior angles. Just to kind of press our knowledge here, alternate exterior angles are also congruent. So we would say that 2 is congruent to 7. All right, last one here, highlighting our transversal, boom. We are working with angles 4 and 5. Looking at this one again, first question I always ask myself, are these angles on the same or opposite sides? I'm noticing opposite, so we're going to have alternate angles here. One's on the left, one's on the right side of this transversal. In this case, though, these are inside angles. They're inside. So we would say that these are alternate interior angles that we're working with. Alternate interior angles are also congruent. So we could say that 4 is congruent to angle 5. Alrighty, I've got one more kind of practice for us here. If we were told that angle 1 was 110 degrees, 110 degrees, could we find everything else in this picture? And you can use any of the angle relationships that we know. So you could even use vertical or linear pair as well. I think to get crazy to start, maybe we use my most favorite vertical angle idea, and we could say that angle 4 is also 110 degrees. And why can we say that? Because of vertical angles. That is going to let us kind of unlock the rest. Maybe we try to be brave here and use one of our new angle relationships. I'm going to highlight our transversal. It's this line T. What we could say is we have this angle 1. And angle 1 is an alternate exterior angle with angle 8. So we could say that angle 8 is also 110 degrees because of alternate exterior angles. It's an alternate exterior with angle 8. We could use that same idea for angle, 5? Because 4 and 5 are alternate interior angles, which means that they would be congruent. So these ones we could say are both 110. Now I'm going to challenge us to kind of think about the consecutive or same side interior or same side exterior. So we can think about these ideas because we could say that 4 and 6 have a relationship. 4 and 6 are same side interior angles, and these ones always add up to 180 degrees. They're supplementary. So that tells me I could do 180 minus 110 to get 70 degrees for angle 6. And again, that was the same side or the consecutive interior angles. We could do that same idea actually for angle 3 as well. We could say that these ones added together should equal 180, which would also be making angle 3 70 degrees. All right, we only have 2 more to find. When we're looking at our last ones, what we need angle 2 and we need angle 7. A lot of different ways that we could find these ones now. I think, again, I'm going to use my most favorite way, which is vertical angles. If we know that angle 3 is 70, so is angle 2. And likewise, if angle 6 is 70, so is angle 7. But you could also use our linear pair idea of forming that straight line. You could use any of the angle relationships that we have. Now we have a really, really big toolbox to help us use all of those different angle relationships in a case like this. Alrighty, that was lesson 1 of unit 3. I'm going to leave you here. These angle relationships are super duper duper important, so make sure you are looking at that graphic organizer we made and looking at the homework. And if you have any questions, please let me know because we'll use these angle relationships from here on out. With that, I will leave you, but if you have questions, you can Schoology message me or go ahead and try your homework now. Thanks, bye guys.